So today we're going to go over a question relating to a deferred perpetuity. A perpetuity in general, just as a reminder, is when we have an indefinite series of cash flows coming from a certain investment amount. And when it comes to a deferred perpetuity, we're talking about an infinite series of cash flows whose term begins after a certain period of time. So basically, we're waiting a deferment period. So for that deferment period, we're just letting the money grow. We're not taking any cash flow from it. And then after that deferment period is over, then we're getting cash flow after that. So the benefit of waiting, if you're able to, is then you give that money an opportunity to grow on its own for compound interest to do its thing for whatever the deferment period is. And then when you do start taking cash flows from it, those cash flows are going to be bigger than they would have been had you started earlier. So that's the benefit. That's why anyone would wait when you could just start taking out cash flows earlier on. So here's an example. It says, what is the present value, meaning how much money would we have to front today, of a $5,000 monthly perpetuity in which the first payment is made within 6 months, assuming a 10% annual interest rate? Okay, so here's what we know. We know that A is $5,000, right? We want this every month. So this could be like a retirement perpetuity would be a great example for this. Since $5,000 a month, that's quite a decent chunk of money for not actually doing anything. And then we have I, which is the investment value, which is 10% annually. Now, in this case, because this payment is going to be made monthly, we have to take that 10% and we have to divide by 12 in order to get the monthly investment amount. So 0.1 divided by 12 gives us 0.0083 repeating. And then we have to illustrate this situation that's going on. So basically what we want is we want to know, okay, how much would we have to set aside today into this perpetuity in order for us to get paid in 6 months? So in other words, the deferment period is 6 months. And so what I'm going to do is I'm going to draw kind of a timeline here like this. I'm going to start with right now, we're at month 0. Then we have month 1, month 2, month 3, month 4, month 5, month 6, month 7, month 8, and we're just going to keep going on until month infinity, right? We're just going to keep doing this. And so infinitely, we're making $5,000 each month, and that is starting on month 6, right? Because 6 months is our deferment period. I'm going to label the 5-month mark as PV1. So first we're going to figure out, okay, what if we're not doing this till 5 months from now, and then essentially there is no deferment period, what would PV1 be then? And then we're going to have PV2, present value 2, be here, because based on that amount that we would need here, we can find out what the equivalent amount is based on the time value of money if we were to do this a bit earlier. So that'll make the amount go down since we are putting that money in earlier essentially. So let's start by finding PV1. So PV1 is just going to be the regular equation of A over I, which is equal to $5,000 over 0.0083 repeating. And if I grab my calculator, 5,000 divided by 0.0083 repeating, I get $600,002.40. Okay, so 60,000, or sorry, $600,002.40. So there we go. So if we were going to wait for 5 months, which we are not, but if we were, that is how much we would need in the perpetuity in order to get $5,000 a month. Now that's a lot of money, but keep in mind $5,000 a month, that's pretty great, right? That's quite a lot of money that our investments are doing for us that we no longer have to do. Then we have PV2. So let's say we are going to actually, put in whatever amount of money we need for this perpetuity right now, and then wait, and then start at month 6 to take money out. Well, in that case, we're going to need slightly less set aside because we are setting it aside earlier and we're giving it those 6 months to grow. Now, 6 months isn't that much time to grow, but it will still make a small difference. So let's do that. So for PV2, that's going to be equal to PV1 over 1 plus I, and then to the power 5, because this is going to have 5 months to grow, essentially, before we start, actually getting these payments from this investment, from this perpetuity. So that's going to be $600,000, or $600,002.40 technically, over 1 plus 0.0083 repeating to the power of 5. So let's put that into our calculator. And that is going to give me $575,615.44. And that might seem like a big difference, right? That's almost a $25,000 difference. So, in that sense, that does seem like a big difference. But percentage wise, that's actually not that big a difference, right? So, there we go. Therefore, the amount of money, the present value that we would have to front today in order to, wait 5 months and then on the 6th month start getting this perpetuity at the 10% annual interest rate is $575,000, or $575,615.44.